Hello and welcome to Game and Simulation Programming. My name is Bruce Van Horn. I will be your instructor for this course. And this particular video is going to introduce you to an overview of all of the things that I would like you to learn as fledgling game scripting, game programmers, or whatever you'd like to call yourselves once you gain mastery over creating code that drives interactivity in games and simulations. So I've been teaching here at Richland College for over 20 years now, and obviously all of that hasn't been Unity because Unity hasn't been out that long. But over the course of teaching so many programming courses, I have developed what I like to call a 10-step program. It is designed to teach you exactly what you need in terms of fundamentals, and it works really great if this is your first programming course, and it works even better if you've had a programming course before. So I realize that there is a wide range of students out there. Some of you are taking programming for the first time. This is your first programming course, and others among you have taken many programming courses, or maybe you're self-taught and you're already very comfortable with the basics. And then I suspect there's a wide range of you in the middle where you maybe have taken a course in high school, or you've taken some courses here at Richland College or somewhere else. You've got some exposure. Maybe you've learned a little bit on the job somewhere. And so what we try to do in this course, since it doesn't really have a prerequisite other than introduction to gaming or introduction to multimedia if you're coming from the multimedia side, is to sort of aim at the middle and then tone it down a little bit. Since, however, this is a hybrid course, the neat thing about a hybrid format is that if you're one of these people that's already pretty advanced, you can just skip the lectures that you don't need. But this is the video that I want everyone to start off with. Everyone should watch this because it's going to outline these 10 steps that I want everyone to have mastery of by the end of the course. And if you can master these 10 things in any game scripting language, doesn't matter if it's Unity with C# or Unity script, this same outline, this same approach would work with any language. So if you were going to learn perhaps Cocos 2D with C++, or even JavaScript or Lua, or if you're going to use, say, Unreal. We have some courses at Richland College using Unreal, particularly in level design. If you wanted to learn how to script in that tool, you could use my 10 steps for that as well. And again, it works better every time you learn a different language. It's basically you're taking this framework and you're applying it to whatever tool it is that you want to learn. And this is important because part of your college education should be learning how to learn things and learning how to teach yourself new skills. That, as a programmer, is going to be your most valuable asset. If I just teach you Unity, well, Unity may or may not be around in 5 years. Case in point, I started teaching at Richland College again over 20 years ago with a tool called Authorware, and it's really hard to even find Authorware anymore. And then we switched to Flash, and Flash was good to go for about 10 or 12 years. And then Steve Jobs decided that that Flash had to go. And it seems like overnight Flash died. So tools come and go and paradigms come and go. And it's the most important skill that you can have is having some sort of framework for teaching yourself new languages and new tools. And that's what this course is really about. And it just so happens that we're going to fit Unity and C# as our tools into this framework, and hopefully you'll come out learning a great deal about scripting in Unity, but also how to learn new languages, how to program in general. So this is my first slide. That's why it says 10 steps to mastery. Those Chinese characters off to the side, I hope that says Kung Fu. I don't read or write Chinese. Kung Fu is something that everyone's heard of, right? So most people think of fighting when they think of Kung Fu. But Kung Fu actually means mastery over an art. So there are lots of different styles of Kung Fu that don't have anything to do with fighting. Maybe you've heard of something called Feng Shui, which is considered a style of Kung Fu, but it's for interior designers. So there's lots of different things that apply to this concept, not just fighting, although it's cooler when you're talking about the fighting arts. We're going to sort of develop our 10 steps towards mastery, and hopefully when you get out of the course again, your Unity scripting Kung Fu will be maybe not Bruce Lee level, but hopefully approaching it. Before we jump into sort of dead center about learning about programming in general and Unity programming with C# specifically, I want to touch on one of my favorite subjects from school. Back when I was in college, I took a lot of chemistry courses. Now, I didn't get a degree in chemistry. It just so happened that for whatever reason, I'm pretty good at chemistry, at least in the lab parts. And so I really enjoyed chemistry classes. So I took a few. And so I remember back when I was taking chemistry, realizing that there are a couple of different levels of understanding. And if you remember, the first thing that they taught you about the atom was what we used to call the Bohr model. That's what it's still called because it was developed by a man named Niels Bohr. And he developed this theory very early in scientific history. He sort of came up with it in the early 1900s. And he thought that, rightly so, that all atoms consist of three basic particles: protons, neutrons, and electrons. And you've got these protons and neutrons in the middle. They form something called a nucleus. And then on the outside, you have these electrons that are sort of spinning around the nucleus in what you might think of as an orbit, not unlike the way the moon orbits around the Earth or the Earth orbits around the sun. And so that's fine if you're in the 5th grade. But as soon as you get to the 10th grade, or as soon as you get to college, you learn a different model. You learn that it isn't really that simple. There aren't electrons spinning around in a nice, clean path where you could predict where they're going to be at any given moment in time. We know exactly where the Earth is going to be relative to the sun on any given day, indeed in any given minute of any given day, and it's a very predictable path. However, in chemistry, as electrons travel around the nucleus, they don't travel in a predictable path. Instead of these nice, clean, orbiting paths, there are sort of these clouds around where the electron is likely to be at any given time. And depending on how many electrons there are orbiting an atom, these clouds can take on different shapes. So on the screen now, you're seeing a picture of all the different shapes that these electron clouds can take. And at their simplest level, they're just spheres. But if you look within the picture, you'll see some of them getting pretty funky. They can be donut-shaped, they can be cone-shaped. There's lots of different possibilities, but depending, again, on how many electrons there are, what atoms we're talking about, we understand that it isn't as simple as we thought it was in the 5th grade. And then if you make it past your undergraduate work in chemistry, you move into a different view of what an atom looks like. And on this particular slide, you're seeing this sort of highly mathematical abstract representation of what things look like to someone studying string theory, which is sort of an abstract mathematical science. And they're looking at something completely different, certainly, than what we looked at in the 10th grade through our undergraduate work. And that, again, is a level deeper than what we learned in the 5th grade. So my point in all this is to let you know that there are different levels of understanding, and you can function fairly well with even the basics. And then hopefully we'll move into some of the more advanced material. I doubt in this course that we'll actually get to sort of this PhD level, but that's sort of your challenge as you move through your career, be it an educational career or a professional one. Hopefully I can take you fairly quickly through our version of the Bohr model and then well into our college level programming class. And you'll have not only the fundamentals, but also you'll be able to do some interesting things with your new skills by the end of the course.